All right. So with this class, I'm going to be doing quite a few screen sharing. There will be some polling and some breakout sessions just to kind of mix things up a bit. Today, we probably won't be doing those things, but I want to give you guys a heads up in terms of just to kind of expect those things from time to time, just to make sure that we're all kind of paying attention. I know it's difficult in these types of class settings and use this virtual distance to maintain that attention. And also, one of the things that I like to point out is I don't mind if you have your camera on or off. That's really up to you. At the same time, with the audio, you can feel free to mute yourself when you're not speaking, or you can leave it on if you're in a quiet place. I don't mind. However, don't be surprised if there's some interference. I may go ahead and mute you just to the benefit of everybody else when I'm speaking about a point or if someone else is speaking. So first things first, we can't have the first day of a semester without talking about the syllabus. And so what I'm going to do next, go over the syllabus and answer any questions, comments, or concerns that you may have about the course and the syllabus as it's defined here. So this class, 317, Fluids and Heat Transfer, it's really two courses glued together, which means it's going to be a little fast-paced at times and not so much at others. In the beginning here, I like to go a little slow to kind of ramp up to that level of productivity because I feel it helps, because nobody wants to be given a million things to do all at once. But I will say with that, expect it to ramp up probably over these first couple weeks, such that by the end of week 2, you're probably going to get a better sense of what to expect in terms of workload and time requirements for the rest of the semester. So with that, you're here. Like I said, I'm Dr. Lopez. My phone number is there, email address. Never hesitate to email me if you have any questions, whether it be for homework or on a topic. Anderson 228 is my office. I'm probably going to go ahead and do the virtual office hours just for convenience. In terms of what this course covers, this course discusses key principles associated with fluid mechanics and heat transfer as it relates to application in chemical engineering, with some emphasis in process engineering. And so what that means is we're going to be looking a lot at, for this first half, focusing on fluid mechanics, looking at mass and energy balances as it relates to fluids and piping systems, to identify energy requirements for transporting fluids, as well as understanding the characteristics associated with pumps, compressors, valves, and how those relate to those mass and energy balances in chemical processing systems. The second half of the course is geared more towards the heat transfer principles and how it relates to essentially the operation of heat transfer equipment like heat exchangers, boiling and evaporation systems, flash systems, and so on and so forth. More specifically, I've identified learning objectives over the course. One other thing I like to note in these learning objectives is this concept associated with momentum balances, because a lot of times this is the first course where you'll really understand, or at least attempt to understand, what a momentum balance is and how it applies in chemical processes. And so that's definitely a point where the students will struggle, and it's also a measure of uniqueness for this course in terms of what is a momentum balance and how does it apply at both the microscopic scale when you're looking at microfluidic type systems, as well as a macroscopic scale when you're actually talking about fluid transferring or transporting through pipes and pipe networks. So that's something to keep in mind. Um, some other things that we touch base on is compressible flow. A lot of times in other classes, you really don't talk about the implications of moving gases through systems and what that means. And so that's a big topic we explore in this class. Any questions thus far? No? Great. Okay, so let's talk about the methods of instruction, class expectations, and a little bit of time management. Um, as of right now, this class is going to be operating simply as a remote for a lot of reasons, and I won't take class time to talk about those. If you want to talk about those, we can talk about them in office hours. I don't mind at all. But the way this is going to operate is going to be largely through a Blackboard type structure, as well as participation in these meetings where we will go over lecture topics, we will have discussion over these topics, and we will work on some problems to give you confidence and familiarity with these course concepts. And so I'm hoping by the next couple weeks you'll start to get a little more comfortable and familiar with this method of instruction. And should you have any issues, always feel free to reach out and talk with me. I'm always happy to adjust my instruction style to ensure that you're participating and learning as much as you can. I know we would all like to be in a face-to-face system, but I felt that it would be better served to provide you a means to interact with me a few times a week than to have an unfortunate flipped model where I was really only able to meet with, and interact with each student once a week, because I feel that contact time is extremely important when it comes to learning and understanding these concepts. So I feel like the more contact time I can have with you all, the better it will be, even though it may not be in the way that we would like. Um, Time management. This isn't a new section I developed for this class, primarily because, well, in the past this was primarily a senior course, and this class butts up with the wonderful senior design, and I found that there were a lot of instances where students were having to make unfortunate choices between this class and design. And since design is king, the choices were always such that design took precedent. And, ignoring the discussion of whether that's a good option or not, I felt it more helpful to give you an idea of expectations for the class so that going in on day one what types of assignments and efforts are required for this course and the anticipated time commitments should be. Now, I know your freshman year when you're taking those introductory courses, they say, you should anticipate 2 to 3 hours of studying and engagement, homework and stuff per every hour in actual class and actual lecture. And so with that in mind, I designed this course such that it should only require about 9 to 10 hours a week of engagement to ensure you're essentially keeping up with the course. And and to help you, I broke that down by activity with homework, quizzes, the synthesis assignments I'll talk about in a second, textbook reading or skimming, depending on how good you are at skimming, as well as getting in with the lectures, interacting with me in office hours, and then just general study and review. And so this is kind of an idea so that you know what to expect for this class in terms of those commitments. And it's also a way of, one, if you're struggling with this course, you can ask yourself, am I making this commitment in terms of, am I really putting 9 or 10 hours, or is it really falling down into the 3 to 5 hour category? Or on the flip side with that, if you're finding that, okay, I'm spending 12 hours on this class and I'm still struggling, then you can come to me and say, hey, I'm having an issue. I'm putting in the time and this homework assignment is killing, me, and I think it's killing everybody. Let's talk about that. And I'm more than happy to work with you all in those instances. My job here is to, teach you this material and also help you develop the skill sets associated with these concepts. And whether that means going slower, adjusting a homework problem because it's just a little more than I had originally anticipated, or re-explaining something or breaking something down in a different way, I am more than happy to do that because I want to make sure you all have that opportunity to succeed. And so this is how I had um, helped as a way to ensure that that is possible, just to make sure, we're all kind of on that same page. Is there any questions on that? Does that make sense? Yes, no, maybe so. All right. So, on that topic, my ground rules for interaction and engagement. This is a point that I've had some students really like, some students not like so much. I like to make assignments and activities that require some form of interaction and communication to succeed. Primarily because you all are studying to be engineers and to go off and have careers in the field of engineering or a related field. And when you go off into that field, you're never going to have what I consider a well-defined problem, where you say, okay, your boss isn't going to hand this homework assignment to you and say, I want this done by 5 o'clock. I need these calculations done. Go ahead and do that and get back to me. That's never going to happen. And if it does, that's a rare instance. A lot of times it's going to be, hey, I need you to explore the implications of improving productivity in this on this line by 10%. What's that going to do to our system? There's going to be a lot of uncertainty and a lot of duties and tasks. And what that means is, in order to effectively address those issues and solve those problems, communication and interaction becomes a large part of those activities. Meaning, you're going to have to talk with others, gain information, and make decisions either individually or collectively on a team in order to perform those duties and tasks effectively. And with that in mind, some of the homework and assignments that you will have to complete in this class are going to require those same skills in order to do it successfully. What that means is I may ask a vague question or an ill-defined problem such that you have to either seek out information within the textbook, within the lecture notes, or through discussions with me back and forth to narrow down your options and to determine the best strategy for completing those assignments. And so I'm saying, simply put, is you're going to have to reach out with me on some things to really get a good sense of what it is I'm asking, and that's done by design. Because in addition to knowledge acquisition, these courses are designed for skill development. And I think this is an important skill that any engineer should be comfortable with. And it's more than just David's make a good PowerPoint and have a safety minute. Those are important. But at the same time, you should develop a skill where you're comfortable asking for help, gaining clarification, and communicating regularly with others in the performance of assignments, duties, and tasks. Does that make sense? Everyone kind of get that? Hopefully, laying this out here, plain and simple, I want you guys to have that confidence to reach out with me. And also have the confidence to say, hey, Dr. Lopez, this doesn't make sense. You're really bad at spelling. That happens a lot, I'll admit. And I'm always happy to go back and say, yeah, that's wrong. Let's figure it out and let's fix it. So never be uncertain to do that. Feel free. Because like I said, I want to work with you guys, and I'm always happy to do what's necessary. All right, so homework and assignment submissions. Oh, I need to change this a little bit. So typically, homework's going to be assigned every Thursday in Blackboard and due on Friday, Midnight in Blackboard. I've changed my structure a little bit. This largely holds true. However, in lieu of having things separated and isolated in Blackboard like I've done in the past, I'm organizing this course under the framework of modules that will happen week to week. And so I will release the next week's module every Thursday, and that will include all the lecture overviews, the required textbook reading, and all of that information, as well as the homeworks, assignments, and quizzes. And that will all be due on Friday in terms of those homework assignments. Typically, I will allow one late homework with no penalty because I know life happens. And so if something comes up, you don't have to ask for that makeup. You just say, hey, it's probably not going to get turned in this week, and I'm saying, okay, that's fine. I allow everybody to have a free pass. And beyond that, if there's a late issue, I typically don't accept it outside of extreme circumstance. So what I tell students is, don't use your free pass for something trivial like I didn't feel like doing it, or poor time management. I understand that happens. I always try to say, save that free pass for the second half of the semester when things get really hairy, because it's better to burn it or to use it in those circumstances than to be mad at yourself because something happened in the first 3 weeks. Granted, if it's something extremely extenuating, do what you got to do. As I said, it's designed because life happens. But that's my advice in regards to that. Also, in terms of homework, I'm doing things a little differently than I've done in the past. I'm creating 2 sets of homework assignments. One that I'm really calling just homework. It's just problems that it's done typical and I've done traditionally, where they're based on the concepts. You do the calculations, you perform the work, you get the answer, you circle it, you write a smiley face, and you submit it, and it gets credit and graded as normal. Then the second assignment type, which is a little different, is I'm calling them synthesis assignments, because they're assignments that are designed to take the lecture contents a little further and impart some of your ingenuity and creativity. And so these are going to be, once again, some of those ill-defined problems, and they're going to be designed intentionally like that. So just, kind of be prepared, take a heads up that those types of things are going to happen. Like, I think this week's was just a simple create a 60-second video introducing yourself and telling me a little bit about your course expectations. Some of them will be videos, some of them might be writing assignments, some of them will be about, hey, give me a preliminary design of how you would address this type of problem. So they're going to be fairly open-ended, and they're a way for you all to engage in this course in a way that's a little more meaningful beyond just, all right, find X, what's the horsepower requirement for this pump, or things like that. The next thing I want to talk about is quizzes. So quizzes will be in this course. They're going to be 5 questions, multiple choice in Blackboard. You'll have 30 minutes to complete the quiz. And I recommend doing the quizzes probably at the end of the week, once you've finished the homework and all the assignments and the reading. And so with that, I've put the assignments, homework assignments, synthesis assignments will be due every Friday at the end of the day. I think I updated that. And the quizzes will be due on Sunday at the end of the day prior to the new week rolling over. So they're going to be like last minute, just, I don't want to say last minute, but the end of the module sort of check in of, did you really get some of these key concepts, or were there some things that you may need to review? And, just be prepared, because with them being multiple choice, a lot of times they can come off as being a little difficult than ideal. So just like I said, make sure you're comfortable with those concepts prior to kind of jumping into them. All right, exams for this class, we will have 2 midterms and a final. The first midterm will be end of September, September 29th, in the evenings, 6 to 9 p.m. The second will be at the end of October, and the final will be, at the end of November as stipulated by administration. I choose 6 to 9 p.m. exams because I like giving students plenty of time to complete an exam. I also choose it because I assume the majority of students, I really haven't run into it yet where someone has a class on top of it. And at the same time, I put it in the syllabus so that if you are, working in a position part-time, you kind of know well ahead of time what days you need to ask off. It's gonna be through this Blackboard. I will release the exam at 6 p.m. and it will be due in the submission box by 9 p.m. I will be online that evening to answer questions. And it will be open book, open notes, because in this format, you can't have an equation sheet, and there's no way for me to police that, so I'm not gonna try. So open book, open notes, just not open friend. And if you have an issue with that, please let me know. And if anything comes up, I deal with that on a case-by-case basis. All right, now touching base, we're almost finished. I know sometimes this can be a slog. The required book is McCabe Smith and Harriet, Unit Operations, 7th edition. Now, my caveat and 2 cents on the book, it's a decent book. However, it's not a textbook in that it's not really designed to teach you material. It's designed to refresh material that you already kind of know. So it comes off as more of a reference text than a true teaching textbook. So what that means is if you're really looking for a textbook that's going to help you learn some of the material, I strongly recommend looking at some of the secondary texts I've identified. Primarily when you're looking at this first section of the class, the Wilkes Fluid Mechanics for Chemical Engineers in Prentice Hall, that's a really good textbook to help teach yourself concepts in fluid mechanics when you're struggling outside of class. I don't know how much it costs, but I know there's old editions for it that are probably going to be relatively cheap. So if you're one of those people that really wants a really good textbook that's going to really, kind of drive some things home for you, I recommend that one. In terms of the fluid and the heat transfer part, I definitely recommend Sengal's book because it's also an excellent text. So a lot of times I get, why don't you just require those 2 books? They really don't like it when I, require 2 textbooks because nobody wants to buy 2. And at the same time, I know unit operations is used in separations. And so it's really for those reasons why unit operations is still the required book for this class, because the material's there, it's just kind of hard to digest in how it's presented. And like I said, if you have questions, I'm always happy to help and address those. So just kind of be prepared for some difficulty, getting through that book. Any questions at this point? I'll pause for a second. No? All right, we'll keep going. So, in terms of, I kind of have to have internet access to get on Zoom. I put that preferred high-speed internet, but I'm not gonna. I can't require an internet connection. I wish the utility companies were better than they are, but capitalism is king. All I can say in terms of some of these policies, let me know if you have issues interacting with Blackboard, logging on, finding information, or if something comes up with the Zoom, getting in and out. I'm expecting there to be issues. I'm expecting probably in some of these lectures that my computer is going to crash and I'm going to just magically disappear and you're all going to be sitting here staring at each other going, where did he go? I will jump back in. It usually takes me a few minutes to reboot and jump back in. So just don't worry if something happens. I'll fix it and I'll come back. So don't get worried if something happens. I'll mark you present and all of that. And we'll get through it together. Trying to think of what other last minute topics we got. Okay, going back. Grading. This is the grading scheme that I have for this class. The homework and synthesis assignments will be about 25% of the class grade. Midterm exams will be 35%. That means each midterm will be about 17.5% of your grades. So just know that understand that that's the expectation. Attendance will be 10%, which I'll take at various times throughout the semester. Quizzes will be 5% because as they're difficult, I don't want to put a whole lot of weight on them because I don't want it to like kill a person's grade, but I want it to use it as a good measure to whether people are kind of getting key concepts or not. And then finally, final exams are 25% of course grade. And so you'll note that between the midterms and the final, that's 60% of the grade. And so this class is very heavily weighted on course exams. I do that primarily because there's no good way for me to ensure that homework's being done individually by each student. I'm all for collaboration in terms of homework, but I know the reality of the WeChats and things, and I'm sure you guys have your junior WeChat group and senior WeChat group, or I don't know, you guys do answers through TikTok videos and interpretive dance, whatever it takes for y'all. So I get it. But exams are a little more onus in terms of individualized effort. And that's why I like to give more weight to those. In terms of the grading scale, I know the university uses like a plus minus scale, but nobody likes minuses. So I use what I call the plus naught scale, where I'm going to give you an A if you have a 90 or above. I'm going to give you that B plus because, GPA, yay. And like I said, B, C, D, and F. The only thing that, my, weirdish rule is I don't give a C minus. And I do this for a couple reasons. But the simplest reason is, and over the past few years in teaching this course, I don't like what I call students trying to fly under the radar, where they're, you need a 70 to pass, so a 70 is what I'm going to get. And so I ask a little bit more of you all in terms of don't try to be that student, because you might get burned and nobody wants to get burned by that. And so shoot for that C plus, if anything, at least. In this class, the majority of people do get A's and B's with a few C's, but there have been some D's and F's. And the last thing I want to do is assign a D or an F. I want everybody to succeed. But sometimes people have to learn the hard way. So please don't be the person that learns the hard way. And last but not least, attendance policy. Class attendance is gonna be mandatory, because I believe if you're not here, you're not really, investing in yourself. You pay tuition in one form or fashion, you might as well get what you pay for. But as I say, I know life happens and other things will occur. And so, if you're sick or you have to go through COVID, quarantine policy, whatever happens, I get it. All I ask is you keep me in the loop and let me know. If you know well ahead of time that you're going to be gone. I had a student who just left because he got invited to the Masters and didn't let me know, which was not very nice. But if you know ahead of time, just let me know. And if it's last minute, just give me a heads up, and I'll give you that excused absence, so long it was as it wasn't I was stuck in the Dairy Queen line. Things like that. Because I think attendance is important. The syllabus is just some policies. The one thing I will say is I'm happy to provide any accommodation for any student who needs it. All I ask is that if you would like to request an accommodation, the most common being extended time on tests, please let me know well ahead of time, because there's nothing I hate more than getting an accommodation request the day of or the day before an exam, because because I really don't want to have to hang out with somebody till 10:30 at night, because they told me last minute that they would like the accommodation. I'd like to work around it and work with the student well in advance. So please, like I said, communication is key, and we're all learning, hoping to get better at it. So let's work together. And the rest is just policy that I was encouraged to put in the syllabus, all of those good things. All right, moving on. Any questions on the syllabus, the class structure, and expectations? I will gauge by your silence that's resounding no, that you highly enjoyed the syllabus discussion. 10 out of 10, would recommend. And you are excited to see. Thank you, Walker, for the thumbs up. I appreciate the emoji. Always. I'd like to have fun with this as much as that. If it helps, I'm always willing to jump on a ridiculous background. I've got some fun ones. I want to have fun as well as learn. So, if you guys want to vote for a good background, always, or anything else that we can do to engage, I'm always willing to jump in and do those things. In terms of the class structure and schedule, let me see, I'll jump on the schedule. I made a tentative schedule that is subject to change. So you can get a kind of an idea of when things are going to be due. The only thing that's different is I think I'm probably going to have the synthesis and the homework are going to probably be due on the same day. It's just because I think it will help in terms of maintaining good productivity. I'll update that later this afternoon, because I don't want you to be stuck in between two modules on a week basis. But you get an idea of what to expect on a week-to-week basis, as well as the wonderful topics that we have yet to discuss. I know everybody's favorite from past has always been momentum balances, also known as the 50% problem on midterm 1. Compressible flow, also known as the why does this not work on the homework. Let's see what else people struggle with. I feel like I should give you all a heads up. Transient heat conduction, why are there so many series solutions. And heat exchangers is just fun. Everybody likes heat exchangers. So, just a heads up on things to come. Also, I didn't mention, I will host midterm exam reviews the day before each exam. And in those, I prepare problems, but I also want you all to come with questions beyond just what's on the exam, because I'll tell you that well in advance. But it's a good time to kind of speak now or forever hold your peace on some of the concepts before the actual midterms. And those are always a good time. All right, so we got about 10-15 minutes. So what I'd like to do for the rest of the day is to jump in some review topics and give you all some breakdown of things that I consider are extremely important for this class, even though you already know them, but I tell them to you anyway because people are going to screw them up. I know it's a long title, but I couldn't think of a shorter one.
I think there's a question that someone typed out asking if we follow the chapters in the textbook or be like hopping
Oh,
around between
thanks,
them.
Reed. I just saw that. Yes, that's a good question. Thank you, Carly, and thank you, Reed, for pointing it out. So we will largely follow the chapters in the textbook. However, that will change when we get into heat transfer, because the heat transfer section of unit operations is structured a little odd. So it'll usually be like chapters 1 through 10. I believe we skip the mixing chapter because we don't really get into mixing. That's its own. Chapter 9, agitation and mixing, that's its own monster. And if you want to get into mixing, you can find those people. I know a good expert on mixing, but we don't really jump into that here. And then 10 through 15 is heat transfer. But so basically today we're going to be looking at really chapter 1, which is just review. And then Wednesday, Friday, we're going to look at chapter 2 and maybe get into chapter 3 a little bit. But very good question. Yeah, and I'll try to keep an eye on the chat just in case you have questions. But if you guys see them and I don't, go ahead, holler at me and say, hey, we need this information. Thank you, guys. All right. So the way I like to do lectures, beyond just the wonderful world of Zoom, is I take notes on my computer as I talk, and then I will share those notes as well as the recorded videos of these lectures onto the Blackboard in those modules, so that hopefully by the end of today, you'll see this recording as well as whatever notes I take today on our chapter 1 discussion. So that, it's like I said, if something happens, you still have the videos, you still have my notes, and between that and working with your fellow students, you won't be behind at all. It's my goal, like I said, give you as many tools and resources as you need to succeed. All right, so today's lecture is gonna be, review. And I know I will apologize. I like to do artwork sometimes, but I am a terrible artist. And my handwriting can be terrible. So if you need to know if that's an S or a 3 or a narwhal, you just ask and I will clarify. So we're really just going to talk about today units and dimensions, because this is going to be a point where I sense struggle always happens in this class, even though you kind of already know this. It's the application and how it applies in fluids in particular that's always a struggle. So what is a dimension? Anyone want to take a guess? Now we're getting into existential questions.
Properties that can be measured based on pre-existing properties.
It's true. Property can be measured. Thank you, James. Or calculated. Other measurements. Right? So we measure things and we use that data to come up with values, and we categorize that data in values using units, which I would consider a definitive magnitude of a quantity. Which means when you do a big calculations and you say the answer is 12.57, you're gonna see in the greater what? Here, I like color too, so let's have some fun. Usually kind of looks like this. -1. So don't leave me hanging. Units are important. So we got some common units, right? For temperature, everybody's degrees Fahrenheit. The rest of the world is degrees Celsius. And weird nerd scientists are in Rankine and Kelvin. For pressure, we're all over the place. We got the wonderful bar, atmosphere, millimeters of mercury, torr. What else we got? We got PSI A and PSI G. Kilopascals. We could go on forever. Flow rate, which is important in this class. Well, we can have volumetric or mass flow rate, and we're looking at volumetric flow rate, cubic meters per hour, cubic feet per minute. A big one in this class I'll use is GPM, which stands for gallons per minute. So if you see that in a problem, that's what that means. We'll also talk about work and power and heat. So work, looking at joules or foot-pound forces. Power, we're looking at watts or horsepower. And heat is also a form of power, looking at watts again, or because the English are frustrating, BTU, which stands for British thermal units. And if you want, we can even talk about what's called the therm, which, how much was a therm? I fell out of my head. I think it's 100,000 BTUs. You'll see that when you're looking at heating systems in an industrialized aspect. They'll be like, oh, it's going to be 3 therms. And you're going to be like, what the hell's a therm? But the wonderful world of the English units, which a large part of, I bring this up in the beginning of this class, is primarily because the English system of units is a standard in terms of fluid mechanics and piping systems in the US. And so being able to begrudgingly do those calculations is important for this class. And so we can talk about unit conversions and dimensional analysis as important and key concepts for this course. And I would argue dimensional analysis is the most important tool in this course, because we can develop and derive unit conversions. We can also create engineering formulas. And we can confirm our calculations. And a lot of times when you're faced with a problem and you get a little confused, one thing you can ask yourself is, what are the units of the value or quantity I'm looking for. And if you know the units of the final solution and you know the units of the values that you have, a lot of times the way forward becomes a little more clear. And so let's look at an example of this. So let's say I want to convert 2.6 atmospheres to PSI. So there's a couple ways you can do this. I can just say, well, how many atmospheres or PSI are in an atmosphere? So if I say there's 14.7 PSI in an atmosphere, and by knowing that conversion between these two values, I can do the calculation, and it's fairly straightforward. And all I get is 38.22 PSI. One thing I also like to note is Sig Figures. My rule of thumb is retain as much data as you can when you're doing calculations in terms of digits. But when you're reporting a final answer, a lot of times 2 or 3 significant figures are going to be good enough for as good as I would believe. When you start talking about important concepts in design, especially when you get to the economics, I'm giving you guys a pro tip for when you start talking with David, for those of you that are there. Be careful with the sig figs, because if you're building a $26 million plant and you're going to talk about a pump that costs $8,000, someone up high is going to be like, why the hell are we talking about $8,000 when this whole thing is going to be $26 million, right? So you have to keep those senses of scale in mind when looking at calculations, as well as when you're communicating important things. Any questions on that? I know this is pretty light, pretty simple. You guys have seen this before, but I like to talk about it and go over it because, as I said, these are the places where people are going to stumble, particularly when it comes to unit conversions and dimensional analysis with complex calculations. I think that's a good stopping point for today. I thank you all for attending. I think, yeah, we're at 33, which means everybody's here, I believe. So that's exciting. I wish you all a very excellent semester, and good luck with the rest of your classes. And as always, if you need anything, feel free to email me. I will hold office hours right after this class, as well as once in the afternoon. But if you can't meet during those times, let me know, and I'm happy to work with you individually to find times where you can approach me via the Zoom and ask questions, or if you want to do it via email, I'm always happy to do that. But if not, thank you all for being here. I look forward to talking with you all again on Wednesday, and have a great rest of your day.
Thank you.
All right,
Thank
take
you.
care.
Thank you.
Thank you. Goodbye.
Bye.